But just so you get an idea, so I am head of the Emergent Technologies space within AWS. That's essentially anything to do with connected devices, the cloud of smart devices that includes anything from robotics to aerospace to smart vehicles to the lights that you can remotely control in your home, to also health AI, which is our health life sciences technologies that we're trying to leverage by using these connected intelligence devices. I've been at Amazon now for 9.5 years. It's included the retail side as well as the seller side, and for the past 4.5 years, I've been working in this new AWS space. Does everybody know what AWS does? Okay, so I mean, we're in the right city for that, so I suppose that would be the case. But essentially, we're building the building blocks that other businesses use. And so the idea behind what we're providing in the emergent technology space is to have next generation technologies available. So luckily, one of the things that we're doing a lot of recently is leveraging generative AI in what we're building. I also taught for past, I guess, 12 years now. So this will feel a little lecture-y, I'm sorry. I teach user research and design, and now have an advanced studio class I see a couple of students from, which is really great. And I've worked in a lot of places. In fact, working for that guy right there is one of my favorite jobs. So we had lots of different clients that we had done work for. So the culmination of a lot of this technology is really kind of seeing a new face as we move into this new era of generative AI. So let's first start by thinking about where we're at as far as the stage of development from the retro Wayback Machine. 1982, most folks had computers that looked something like this. And the personal computing space had limited power, limited storage, limited capabilities, but yet it revolutionized the entire industry. And that's because there was this slow evolution of technologies. So when we first started in personal computing, there were these big giant floppy disks. Those held 720 kilobytes. So it was just enough to have like a very low-res, simple game, have really simple graphics, simple applications that you could run. Once we started having 1.4 floppy disk drives, all of a sudden you could store enough to be able to have complex applications available. So when I first started, way back when I was still in college, I worked for a software company that used to ship diskettes for their software. And so the way it worked is that we could afford up to 4 diskettes. So that's 6 megabytes. Compressed data, that works out to be about 18 to 24 megabytes in total for the entire application, for everything it needed to do. So when we moved to CD-ROM, where all of a sudden space was not an issue, I could hold 650 megabytes. Working for that software company, all of a sudden we could do all kinds of crazy things. And it was really exciting because now all of a sudden we weren't limited just by the space that we could store. Then when you combine that with the technology in our ability to communicate wirelessly slowly started to take form. We started with these slow baud modems. I used to have one of these to connect to a BBS years ago, and you could connect and talk to people, and it would require this very slow connection, and somebody would pick up the phone and then it would die, and it was just insane. But when we moved to fiber optics and Wi-Fi, all of a sudden the amount of bandwidth that was necessary went away. And so with that, meant that everything that I was so excited about that I could store on a CD-ROM, now was in the cloud. And so what that meant was that not only could we now have more complex software, but now we could have evergreen software, because you could subscribe to software over the net and it would automatically update whatever you were doing, which all of a sudden meant that you had a significantly more powerful engine to run whatever it was that you wanted, as well as the storage was limitless, so you could have lots and lots of capabilities. So these small increments changed the industry, and those changes allowed for this huge amount of technological boom to happen We've seen lots of crashes as well, but those booms allow for huge amounts of opportunity that come into the digital space. So the way you might want to look at it is how much that evolution is moving. So this is a nanostructured glass data disk. It holds, let's see, what does it say? 360 terabytes of data. And it's hard to put into terms what that is, but it's essentially twice the size of the entire internet. and it can last forever. Meanwhile, not too long ago, you had a hard disk that was, what was it, 2 tons? 1 ton in size, and held 5 megabytes, which is smaller than most of your photo images. Which means that if you have this huge amount of capable data that you can store relatively cheaply, and it's not, and you don't have to worry about the storage being latent, then all of a sudden you have huge amounts of capability of not only what is able to have as an application, but also the storage of data. And the data means that I can now combine lots and lots of things to learn new data on top of it. We'll talk about that in a minute. So just to get an idea, that car that Musk launched into space, it had one of those disks on it in the glove compartment, and it has stored on it the entire contents of the internet in 2014 when it launched. So, rolling back again to 1981, the DOS prompt was how you communicated what you wanted from the computer. And it was super powerful because you could run applications, you could store things, you could access other things that were connected to it. Super powerful. Problem was, you had to memorize what actions were available to you. And it wouldn't do things that the actions did not allow. So if you needed to change a directory, you can't just say, go into a different directory and show me what it's at. You won't understand that. You have to type cd space, the name of the directory, then go into that directory and type dir to look at the contents, and then hopefully you saw it as it spun by. In other words, the things that you have to do are based on command line memorization. You have to know each and every single one of the commands that are available, and it can't do the things that are not available to it if you want to do the same action, but you don't understand and don't know those command lines. So when Alexa rolled out, and mind you, it was 2 years after the rollout of Siri. So Siri came out in 2012. All of a sudden you had a more pliable language model for what you could tell it to do. But how many here has an Alexa? So who here really finds it easy to be able to control what you want it to do with your Alexa? What happened to all those hands? You sort of had your hand. Where's the story? So the thing is that if the example I gave in my class a few weeks ago is that my kids named their nightlight Ninja Dragon. They're boys, that's how it works. And so if I tell it to turn on Ninja Dragon, I am guaranteed 1 out of 2 of those times it starts playing the Imagine Dragons, like guaranteed. And if I don't say it in a specific order, Alexa, turn Ninja Dragon to dark gray. If I don't say it in that exact order, in that exact sequence, it won't do it. Or it'll start playing Imagine Dragons. Because it doesn't have the contextual knowledge. It can't figure out, oh, it's bedtime. This is when the kids usually go to sleep, so now that I know you're here, I'll turn on the nightlight the right color. No, that doesn't work that way. Instead, I have to know the syntax, just like I did back in the DOS days. But here's the thing. You combine with where we're at with the ability of storage being significantly higher and the transfer speeds of data being over fiber optics being limitless, and the processing power of what will be quantum computing will make it so that the cost of computing will be significantly lower. Right now, that is the biggest cost. I don't know if anybody paid attention to the open AI folks, how much they asked for in additional funding, an extra $5 billion. And almost all of that is not to pay for software, it's to pay for the compute power. And then there's access. So now you have more power in your hand, in your smartphone, than that PC you saw was 1 million and a half the amount of compute power that you have in your hand with your phone. So the ability for all these things to be happening allow for this technology that's been struggling to happen with artificial intelligence to now have momentum, because now we can store, now we can compute, now we can send it, and now the co-processing power necessary can be shared. So now all of a sudden, the milestones of artificial intelligence, which was very, very slow going. There's been artificial intelligence attempts since the 70s. And every single time it's based on having a tree of things it can do and then it filling in with context, so that way the tree can grow. But that only limited what it could know and couldn't associate things. So over time, this association of what we're capable started to accelerate. So everyone can think about ChatGPT as being the moment that we all think about for generative AI last year or 2 years ago, but it actually has been happening over a much slower period of time until recently where it's accelerated. So there's some components that are worth knowing about generative AI. There's first, you've got your data. Now, right now, the way that it works is that all of these sites like Claude and ChatGPT, et cetera, they all are siphoning everything they can from any source they can to have the data to work from. Then you have what's called vector storage. And what that is it creates the data association. So that way you can understand how some things are related to other things. So that way, when I just tried to look for a new photo for my LinkedIn to have the inside of the lobby at AWS, it has this weird orange room with a glowing orange logo. It looks kind of cool, so I wanted to put that on my site, or on my LinkedIn banner. So I typed in orange into my iPhoto app. Well, it didn't know I meant color. It thought I meant Orange County, and there was no orange photos at all, because the vector storage data was only based on 4 or 5 different types of models. And so what the models are is what you then build into the knowledge base. So you have the vector storage allows you to have these concepts of how things connect. And then the knowledge base is the rules system that allows it to be have what it needs to work from. So when we're looking, like you're gonna see an example of genomic data that we're using for our life sciences application, it needs all of these white papers, it needs all of the genomic data that's already available through other sources as just being the background. And so that knowledge base allows it to understand what those relationships are. And then the reasoning is the LLM you put on top of that. And then what we're used to and how we look at it is through the RAG. It is, I'm gonna get it wrong, but it's the relational generation. I forget what the augmented generation. So that is what it puts as the very top layer for what is the interface usage that you're going to then use for it. So that way the prompts are built the way you need the prompting to go. And that way, if there's a personality to it, it'll have its own model. That's the RAG that sits on top. So for those that don't know, have anybody used Grok with X? Well, thank you for not giving me any money. But anyway, the Grok has essentially no rules on it. So you can pilfer for all kinds of information, and it will regurgitate things that are actually copyrighted. Meanwhile, if you use Claude, it won't, because the rules system that it's using is designed to then give you better prompting that is going to protect some of the content it's coming from, as well as they're not going to necessarily regurgitate racist comments, etc. So then you got to think about, well, what is all this going to do as opportunities? And there's a ton of them. So we can think about all kinds of different ways that you can improve knowledge management. You can have a better customer experience that can be more contextual to what it is you can provide, because right now, if you need to look up how to fix something on your computer or software, generally that requires being on hold for hours on end in order to be told something you could have found out by looking it up in your documentation, And the documentation generally doesn't give you the information you need because you keep looking for the wrong thing before you find the right thing, and even the right thing doesn't have the connection for the things you need to understand. In other words, having the ability to be able to take what is your goal and the information that it has to work from and synthesize that for context is really, 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 really valuable. And that's what allows for all these other opportunities to happen. So we all saw some really easy wins in the beginning. So the direction-led content was really fun, and it did really cool things. And the reason why direction-led content works so well is that I can tell it, create traditional Japanese landscapes of New York, Seattle, Boston, and San Francisco, and it can be wackadoo crazy, and it doesn't matter, because in that list will be a couple that are pretty good. And I can always refine what I have as a prompt. And so the more that I play with it, I can refine my options until I get things that are just spectacular, that it's generating from scratch, that wouldn't have existed otherwise, that are based on the prompts that I'm providing. And so the value that you get from direction-led content is really, really great. And we see the same thing when it's like, tell me about what's going on with the election that happened, based on the rally that Obama had in Pennsylvania. Like, you can put together a story based on the content that it's pulling from different places and create a story. But here's the thing. Hopefully you've all heard the term hallucination. Yeah. So the thing about it is that it's one thing when you are having to create something from scratch and the accuracy is not necessary, or that you are aware of what it's being used for you. But the thing is about generative AI is it isn't self-aware. And so it can be leveraged in different ways. So one of the things that was really kind of frightening was when the task assistant model started to become part of what the generative AI tooling became available, and it was doing things wrong, and it didn't know it, and it was tricking people. So one of the rollouts they did a couple years back at Google was using an assistant to be able to call restaurants on your behalf, and so I'll play for you that. If I can, hopefully. How do I get the audio to go? I can't hear it because it's not
By
the
the controller is pretty fun to lock.
Oh, here we go. I think.
Available.
Okay, so what you're hearing,
we have to that is a one.
Okay, so what you're hearing is a request to a bot to call on behalf of the person to set up an appointment. The thing that was not self-aware by Google was when they presented this on stage was that no one was aware at who would receive the phone call that they were talking to a real person. And that created lots of unqueasy feelings from people, and Google immediately pulled the function. Okay, now that you got the context, let's go.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So what it could do was cool. How it was manipulating a person, not so cool. And it gives you an idea of the precipice that we're laying on the teetering edge of for what we do with this from an ethical perspective. And it's not like we have a really hard lesson to learn when we don't follow ethics. So for those that don't want to remember or have remembered the 2016 election. But there was, Cambridge Analytica had taken the data for Facebook users, and then they fed in other data into it in order to be able to then cultivate what they thought would be messages that would make them react in certain ways, and then they just tested it with real people. And Facebook pretended they had nothing to do with it. They didn't know about it when it turned out actually they were helping, because they were learning lots of cool lessons about how they could use their algorithms to manipulate what they had as advertising, a messaging that they could do dynamically. So they were taking advantage of it in a way that was manipulating people without them knowing it. Well, the outcome was this alien frog ended up having to go in front of Congress for the third time to defend the fact that he didn't defend his own customers. And so there was, on that day that he spoke, 66% loss in customer trust, 15% drop in activity, and 120 billion in valuation loss. They've recovered from that because Facebook is Facebook. But nobody trusts Facebook the same way. And that's not good. It's one of the reasons why they call themselves Meta now. So there's lots of examples of this. So the thing is that it can get it wrong, and if it gets it wrong, where it can create, in the case over here, where all of a sudden there was allergic reactions that were killing people, not good. This example over here is that they were basing their forecasting on what they would be using generative AI for in order to replace people, which means that the economy has a very high chance of being directly affected if it's not being taken into account. What are the ways that we can then leverage it? So for example, Uber is talking about having 20% of their vehicles being autonomous in the coming 2 years. And by, I can't remember the date, I think it was 2028, it would be as high as 80%. That's a lot of displaced drivers. This one was pretty freaky. So it's like, so what happened was that there's an eating disorder group that had introduced a chatbot in order to help and assist people. Made sense. And so they had very, very stringent rules on what they wanted the chatbot to allow and not allow. Well, one of the things that they had told it was don't give diet advice. Kind of makes sense. These are people with eating disorders. You want to stay away from that. Well, they were getting a lot of people that were asking for having recipes. And so they just wanted good recipes that it would suggest. And so the chatbot company decided to turn it on, did not follow through with the NEPA to validate. But they did it because they figured a lot of people are asking for it. It's got safeguards, it'll be fine because it won't give crazy advice. Well, one of the things that they had not safeguarded is that they were having people create a week diet plan. Well, if you're having a diet plan where it's giving you advice on things that are not enough calories, that sounds like a bad idea to give to people with eating disorders. And coming from that source made it that much worse. It made it seem like it was fine. People trusted it. There's an intellectual property problem, a big one. So the New York Times sued for, I think it was 500 million? Does that number sound right? Does anybody know if they can follow up with me? Because ChatGPT was using New York Times articles and was not validating that the information they were being sucked out was because of the very high cost of journalism to create that content. Another thing that happened with intellectual property was that somebody from Samsung fed in their proto annual review doc into ChatGPT to have it correct. Well, it stored that information, and people actually accidentally came across some of the financial information of Samsung before they had their annual report. Kind of a problem. And then, of course, there's this problem about how can we believe what we see and whether or not it's real. And authentication is now falling into the camp of who you believe, as opposed to there's an authority in place for understanding what is being sent to you has legitimacy. So all these things are creating lots and lots and lots of risk. So, I stole this from a slide I saw yesterday. The way you avoid the pitfalls is remembering that you're not interacting with users, you're interacting with humans. And so the way that we've been looking at the curtails of how we want to frame our generative AI model is by not thinking of users as being what they're consuming, but instead they're human tasks, their jobs to be done, their needs and their goals that are attached to what they're asking for. And so we'll think about it, instead of trying to create an assistant, which sounds authoritarian and authoritative in what it provides, instead assistance. Because I can choose what I decide to receive assistance for, even if it is offered. And so it's important that I'm taking into account that I've got a 20% chance of not being 100% correct with what it is I serve and provide. Instead, what I should be trying to do is assist in the ability to reduce the amount of effort involved in tasks. And if I solve for those problems, it's a huge opportunity within the UI and the design space without having to limit ourselves by worrying about the outcomes that may happen from it. Because we're essentially saying, this is what we think might be the right action, or this is how I can save you time. So how does that look? There's lots of things that we can do. What you're seeing here is an example of one of my employees that created via chat with very, very little experience in coding, and asking the prompt to create the code for them, and while they're creating the code, giving them instructions for what it is they're doing so they can learn along with it. And so the idea is, like, just like you would have somebody sitting next to you to help you guide, I can choose what I want to take and what I don't take, as opposed to it doing it for me, and therefore I'm out of the loop, A, and B, it could be wrong. So this one is by Lovely Amy right here. She created with no code experience for what you built here, right? Is that right? Or very little?
Little.
A cool little app just by using conversational AI. I can't remember which bot you used to do it. So it was ChatGPT.
3.5.
And so it was just a fun little app that she made, and it was all done not through her coding, not through her having to build lots of prototypes, but instead using the assistance of the code being generated by ChatGPT, and then making her ideas come to life from it. So where this has a lot of value as designers is that it comes as a high cost when we want to demonstrate and produce ideas. And if we use it instead for low fidelity examples that have fidelity to them because they can actually operate, then we can actually accomplish with the same amount of time a lot more capability of what we need to do to generate and present our ideas. So in this example, it's actually going to create based on a design system that we have inside of AWS called Cloudscape. Cloudscape is a design system that has lots of different components that are required of us to use whenever we build anything within the AWS console. Now, the thing is though, is that sometimes we want to be able to have stuff be a bit higher fidelity, and so if it can follow by what already exists is the platform componentry to work from, then it can actually create it on its own with just guidance being provided by the chat tool. So you'll see in a second how the code that it created is being slightly edited, and then it's able to produce on the fly the screen that is being prompted to, like, can you create this screen for me with the design system attached. Now this worries UI designers of old. But what it's actually doing is, then this is what it created. And so what it's actually doing is creating a new entire industry for designers. Because now my design system is way more important for the capabilities of its componentry, the capabilities of how it can be flexible, the capabilities of what can sit on top of it. I want to then have a different style to sit on top. And so the fact that it can do this means that I can now not eliminate a role of a front-end engineer, but now operate with an engineer. And I can do things with being a lot more accurate than I could before. So this is hot off the press. This is really cool. I made it blurry on purpose. We have this tool that's building from genomic data and identifying different opportunities for what you can then have as potential genetic-based therapies for people. And so we actually have, because of generative AI, the capability of solving for cancer in our generation, which is mind-blowing because this is something that has killed people in my family. I'm sure all of you know people that have had that impact. And the fact that it's able to identify patterns by you introducing new data, and then it can give you guidance back on its effectiveness, allows you to be able to have a much shorter period of time for things like solving specific types of cancers with the right kinds of therapies a lot faster. And so the way that generative AI is being used here is it's not saying, I'm going to solve it for you, go do it. Instead, it allows you to be able to come up with what we're calling recipes. You take those recipes, apply it to the genomic data that it already has, and then you ask it different things to test for. And then it'll already tell you what it has the propensity of its success. And based on that, you can make your own decisions. So it's saving millions of hours of what would be lost opportunity. So this is a cool app that was built by our prototyping team. And what you're seeing here is a 3D visualization that sits on top of a prototype that we have of a bicycle smart manufacturing location. So we have real versions of this, but we wanted to show as a demo. So this is a demo version. And so what you're seeing is what it's flagged as being something of risk that needs to be addressed based on the machinery, and then what is fine, and then what may be of something that you need to look into. And so where it's using generative AI is being able to determine, I think I need to fast forward a little bit. Come on, buddy, there we go. So here I'm looking at what it's saying are the main, those three things that it flagged as having an issue. And now, come on. There we go. So here, I'm now looking at one of those things that was the robotic arm that it said had an issue. I can now ask it what are the things that it might be the cause of the problem that I'm seeing. It can then provide that information back. And then give you, here we go. And then it can give you opportunities to be able to think of this is what you can do to have it last longer. And then the cool thing is that it can then dynamically give you the right, so based on what I'm prompting it with, it can then pull and create dynamically the right instructional information for how I should maintain the problem. And so here you'll see in a second, hopefully. There we go. It popped up based on what I prompted it. It all of a sudden created for me on the fly the PDF necessary for me to have as instructions for maintaining it. So the idea here is that I can use it not to solve for a problem, but allow me as the owner of the task at hand to solve for it faster. And if you're thinking about it from jobs to be done and goals for your user, then you're not eliminating people, you're not eliminating risks of being wrong, you're instead just helping, which is what assistance should be for generative AI's main purpose. Make sense? This one's a cool one because this one's creating generative UI at the same time. So here, you're seeing an example of, hopefully it's going to play. There we go. This is an example of having data that is pulling from hospital data that is connected to the city of Singapore. And so it has all the city information that's being fed into one source for all of Singapore, Singapore's hospital system. And based on the prompts that you ask it, it asks for where are there where are there issues of beds availability. And so on the fly, it's creating the information that I asked for. It doesn't know what I want. It doesn't have that information like sitting as part of what the application could do. Instead, it's creating it dynamically. And so now, when I look at, I can go into the I can deep dive into it. Let's see if it'll show it in a second. This chart was created dynamically. There was no chart information for it to pull. There was no chart that it has sitting in HTML somewhere. Instead, it took the data. It has 7 or so different templates that it's pulling, kind of like what I was describing of the Cloudscape design system, and then applied it what it thought was the right way to be able to show what it was that I originally asked it. So it created on the fly the UI. So that means if I create the right rules and I create the right LLM for what it needs to be having as its sources, and I have the accuracy parts built in, I can have it be able to create limitless types of UI solutions without having to build UI screen and UI screen and UI screen and UI screen. Instead, I can tell it what I needed to do based on a set of rules and what systems to be able to pull from, and it will do the rest. So the opportunities that we see are truly limitless. I would suggest one of the places you can go is Party Rock. It's cool, it's fun, it's easy, and it's okay to be wrong. I think Ying can speak to how just playing around allowed her to be able to try new things and learn new things, and that expertise doesn't have to be there as an engineer or as a designer. It's more that you are seeing how those two things can synthesize. So I'll show you a couple examples of how we've used Party Rock. So here, I'm doing dynamic somebody at AWS that is a sister team to ours. What they did was they took a a transcript from an interview, fed it into this thing, and then it automatically gave what it saw as the, what happened?
Somebody flushed the
Flushed
toilet.
the toilet.
Turned off the TV.
That's a cool feature.
Yeah.